We're going to do an experiment, an activity, that simulates how water gets into cell membranes by a process called osmosis. It's also somewhat similar to how other types of nutrients, and if you've been in class with me yet this week, how electrons, how ions flow into cells and out of cells as well. That sounds really complicated, but really what we're doing is not. This is going to be about how things like cells and bigger stuff like gummy bears absorb things. What you'll need for this experiment: 2 small containers, half cup measuring cup, a half teaspoon, a ruler, some salt, and you'll need 3 gummy bears. You'll need at least 3 gummy bears, maybe more. The activity is quite simple. You take half a cup of water and you pour it into each container. Then you take your half teaspoon of salt. I'm going to do a generous half teaspoon since I'm using kosher salt. It's bigger than regular salt. Pour it in and stir it until the salt is all dissolved. Now what you're going to do is measure a gummy bear. They should all be basically the same. I'm going to use my metric side of the ruler. So this Haribo gummy bear is 2.3 centimeters or 23 millimeters. I'm going to write that down. So I wrote 23 millimeters dry, because now we're going to take one of the gummy bears and I'm going to put the red one into the salt. I'm going to put the yellow one into the plain water. And the green one I'm going to leave out. And I'm going to write that information down so I don't forget. And now what we're going to do is we're going to walk away. We're going to leave them somewhere safe where they won't get knocked over. And we're going to come back tomorrow. And we're going to see if they've changed size. You might also consider putting your dry gummy bear in a container too. You don't want to leave a gummy bear out on the counter to attract ants. See you tomorrow. Welcome back. Good morning. All right, so these have been sitting overnight. Our red was in salt water. Our yellow was in just regular water. And then green was our control and just sat there. So now what we do is we measure to see. All right, so let's see. Did the size of the green one change? I'll measure it again, and it's at about 22 millimeter here and there. Is not going to make a difference. So this one really hasn't changed at all. I emptied the water out of each of them, and now we're going to measure them. They're really slippery. They spent all night absorbing water. And they want to get away. Look at this big feller. I would say it's about 37 millimeters, so I'm going to write that one down. So the green one dry was still 22 millimeters, so about the same size. The yellow one in the water is now at 37 millimeters. It increased in length 14 millimeters. Okay, so we're just going to slide that feller up there. That's funny. It doesn't feel like doesn't feel like anything. 33 millimeters. So what happened here? Why did the gummy bear grow at all? This one didn't grow. The gummy bear acts like the cell membrane, the cell wall of a cell. If you remember from class, every cell has a wall. Now the gelatin, the goo that the gummy bear is made of, acts a little bit like a cell wall. There is not much water in a gummy bear. It's mostly sugar and gelatin. And so the water, pressure on the outside, the water wants to move into where the sugar is. And so the gummy bear gelatin starts absorbing more and more and more and more until eventually the gummy bear can't grow anymore because there's about the same amount of water inside as there is in the same area outside. So the gummy bear grows because of the movement of water, which is called osmosis. And osmosis is the movement of water from where there's a lot of water to where there's very little water. The pressure of the water makes it want to move. So why is the red gummy bear not as big as the yellow one? As in, why didn't it absorb as much water as the yellow one did? Well, it must have something to do with the salt that we put in the water. So to kind of really drive that point home, what I've done is I've taken an orange gummy bear. I measured it. It's 22 millimeters. They all seem to be about 22 to 23 millimeters. And I've taken another half cup of water. Into this, though, instead of a teaspoon, now I've added 2 tablespoons of salt. 2 of these to this. And it took a while to get all that salt to absorb into there. Now I'm going to, oops, slippery. I'm going to put it into the very salty water, and we're going to leave that for about 12 hours, which is what I left the last ones for, and we're going to see what happens. Just out of curiosity, what would happen if we take our water-soaked gummy bear and we put it in another container of salt? So I put another 2 tablespoons of salt in here. What would happen if I put our water-soaked gummy bear in there? Ooh, it floats. It's kind of fun. I'm going to leave it. See what happens. It's another science experiment. Maybe it will stay exactly the same. Maybe nothing will change. Or maybe something will happen. There's only one way to find out. So, here we are the next day. And we have our gummy bear still. This was that green gummy bear that we didn't do anything to. Still the same gummy bear. This is our red gummy bear. This is the one that was in salt water, so it didn't get as big. It's shrunk down a bit because these just dried out. But these are the 2 we're thinking about here. These are the ones that I put in salt water. Now let's look first at the one. This was 2 tablespoons of salt water and half a cup. Let's look at the one that was just sitting in salt water. And I just dropped it in. Regular gummy bear. Okay. So it was originally 22 millimeters, 22 or 23. And now it is actually shrunk down to 20 millimeters or 2 centimeters. So it actually lost water to the gummy bear. Okay? But what's even more fun, now I'm not going to eat this now because yeah, it's covered in salt. Salty gummy bear? However, this was the gummy bear that had soaked in water overnight and got really big. So as an experiment, I thought I'd take it and put it into the salt water and see if it would shrink. And sure enough, it's down to 15 millimeters. There's like nothing left of it. So what's going on? It got bigger in regular water. It soaked up water. But then in salt water, it actually shrunk. It actually lost some of its volume. And when it was big originally, and then you put it in salt water, it basically looked like a jelly bean now. Here's the basic idea of what's happening. This is not easy to quite understand. I'm not sure I understand it entirely, but this is what's actually happening inside the gummy bear. On the left is our regular old gummy bear, just sitting out in the air. It's mostly made of sugar, and it has just a little water. In the middle is the gummy bear in regular water, and on the right is the gummy bear in salt water. After several hours of sitting in the water, we can see a change. What the water is trying to do is even out how much water there is inside the gummy bear versus outside in the regular water that has nothing else in it. It's just water. Since there isn't much water in the gummy bear to begin with, the water flows into the gummy bear, swelling it up and making it bigger. This is osmosis. But in the case of the gummy bear in salty water, there is already something in the water besides water. There's salt. Just like there is something in the gummy bear besides water. There's sugar. So the water fills in the gummy bear only until there is as much sugar and water inside the gummy bear as there is salt and water outside the gummy bear. Then, if we take our huge swollen gummy bear, the gummy bear that's the yellow one that's full of water, and we put it in extremely salty water,
Now there's way more water to sugar in the gummy bear than there is water to salt outside. So the water tries to even things out by flowing out of the gummy bear, right? So the gummy bear is actually waterier than the water because the water has so much salt in it. So the gummy bear loses water. It goes out into the salt water. And so the gummy bear itself shrinks. It's the same idea when you put the regular size gummy bear into the extremely salty water. Even that little bit of water inside the gummy bear flows out because there's so much salt in the water that the gummy bear is still actually just slightly waterier than the salt water around it.
Well, I hope you learned something about osmosis and how water moves and a bit about physics. And I know I did. And now if you excuse me, I'm off to eat the rest of the bag of gummy bears.